Today we're going to take a look at section 9.2, which is about graphing exponential functions. So what is an exponential function? An exponential function has a positive numerical base, other than a 1, and a variable for an exponent. So these two pieces down here, f of x equals a times b to the x, and y equals a times b to the x, those are exponential functions. So a will be some constant, b is the base, so it's a positive numerical value other than 1, and x is our variable. Okay, so there are two different types of exponential models, and they are growth models and decay models. So if the base b is greater than 1, then we have an exponential growth model. And if we have the base is between 0 and 1, because it can't be negative, then we're going to have an exponential decay model. Okay. So let's see what these graphs are going to look like. So we're going to complete these two tables and then graph, and then we're going to take a look at what would happen if the base was a fraction between 0 and 1 instead. Okay, so we're just going to evaluate these and fill in these table of values. So when I'm looking at y equals 2 to the x power, if I want to figure out what is y when x equals negative 2, that's really just saying, well, what's 2 to the negative 2 power? Negative exponent means make it 1 over. So this is really 1 over 2 squared, which is 1/4. So that is 0.25. Okay. If I do 2 to the negative 1 power, that comes out to 1 over 2 to the first power, which is really just 1 over 2. So that's 0.5. All right. For x equals 0, we have 2 to the 0 power, but anything to the 0 power is 1, so we just have a 1 there. If we have 2 to the first power, that's really just 2. And if we have 2 to the second power, that comes out to 4. Okay. So we want to go ahead and plot those points. So when we have, let's see, negative 2 1/4 would be just above, right about there. And then we have negative 1 1/2. Then we have 0, 1. I'll make these dots a little bit bigger, easier to see. There we go. And then we have 1, 2. And, oh, that's a little bit off. 1, 2, and 2, 4. And if we were to go through and graph more points over on the right-hand side, they would be getting steeper and steeper. And off to the left, if I were to plug in, say, negative 3, I would get 1/8. If I plug in negative 4, I get 1/16. I get a smaller and smaller fraction. So you can see there's a bit of a bend to this graph. Kind of almost looks like a branch of a rational graph. It's going to start over here. Oops. It's going to start over here and then curve upward like this. Okay. All right, and what this graph is going to have is it's going to have a horizontal asymptote. Okay, that horizontal asymptote is down here along the x-axis. So there's an HA here. And that's because no matter what I plug in for x, the smaller the x value gets, the more negative it is, the smaller of a fraction or a decimal I get, but I'll never actually make it all the way down to y equals 0, and I'll never make it into the negatives. So as I go off to the left in this direction, I'm getting closer and closer to y equals 0, but I'll never actually get there. Okay? Off to the right, I'm going to grow exponentially. I'm going to grow without bound, and that's because if I plug in x equals 3, I'm going to get 2 to the third is 8. If I plug in something like x equals 100, I'm going to get 2 to the 100th power, which is a very large number. So this is going to grow forever, but there is no vertical asymptote because there are no domain restrictions when I'm looking at 2 to an exponent. I can raise 2 to any exponent I want and get an answer. Okay? So that is graphing y equals 2 to the x. So the question then becomes, well, how will this modify if I have a negative out in front? So now for this second function over here, y equals negative 2 to the x, you can think of that as being negative 2, negative parentheses 2 to the x. So that's like saying a equals negative 1. Okay. So we're going to go through and evaluate this. So if we do the negative 2 power, we're going to do negative 2 to the negative 2. So that's going to become just negative 1 over 2 squared. So it comes out to negative 1/4. Okay. So we're going to have negative 0.25. Oops. Doesn't seem to want to let me write right there for a second. Hold on. There we go. All right. And then if I do negative 1, I'm going to have negative parentheses 2 to the negative 1, which is negative 1 over 2 to the first, which is just negative 1/2, so negative 0.5. All right, and I bet you've probably noticed the pattern that we have going on here, and that's the fact that if we look at the y values from the original table and look at the y values in our new table, we really have the same y values, it's just now they're all negative. So this is going to be a negative 1, a negative 2, and a negative 4. Okay, so if I go ahead and plot those points, I'm going to have negative 2, negative 1/4, negative 2, negative 1, negative 1/2, 0, negative 1, 1, negative 2, and 2, negative 4. So that function is going to be the direct reflection of the one that we had before it. Okay? Both of these are considered to be growth models, and that's because the base is bigger than 1. However, I do want to point out that the graph on the right, again, we have that horizontal asymptote here. The graph on the right looks like it's going down, but because it starts off flat and then it is, the distance in between the points is getting bigger and bigger, that's why it's a growth model. As you go from left to right, the differences between the points are getting larger. Okay, so those are two examples of a growth model. So the one on the left, we're going to call that a positive growth model because there was a positive a value out in front because it was positive 2 to the x. And the one on the right, we're going to call that our negative growth model because it's reflected and the a value was negative. Okay, so now we're going to take a look at, well, what does a decay model look like? So the base is now going to be a fraction. So we're going to do 1/2 power. Okay, so for this first one, y equals 1/2 to the x. Okay, that's what we're going to work on first. I want to do 1/2 to the negative 2 power. So 1/2 to the negative 2 means do the reciprocal of 1/2 to the positive 2 power, which is really just 2 squared, which comes out to 4. Okay, 1/2 to the negative 1 power means do the reciprocal of 1/2 to the positive first power. So that's a 2. And then when I do 1/2 to the 0 power, well, anything to the 0 power is 1, so this is a 1. And then if I do 1/2 to the first power, I get 1/2 or 0.5. And if I do 1/2 to the second, that's 1/4. So that's 0.25. Okay, so those points, when I have x equals negative 2, I have y equals 4. And then when I have negative 1, I have a y value of 2, 0, 1, 1, 1/2, and 2, 1/4. So you can still see that it has that bend to it, but now it's going in the opposite direction. Instead of starting flat and getting steeper, it's starting steeper and getting flatter. So there's going to be that horizontal asymptote again. So I'm going to draw that in. So we have an HA here. And every exponential graph is going to have a horizontal asymptote. And then when I go ahead and draw this, connecting the points, it'll go like this. Okay. So now we're going to take a look at, let's label this. This is our positive decay model. And again, this is a decay model because the base was 1/2 between 0 and 1. All right, now we want to take a look at the table of values for our fourth and final one here. And I bet you may have already figured out that because it's just negative instead of positive 1/2 to the x, we are going to go ahead and just have the exact same y values we have in the table to the left, but we're going to have negative. So this is going to be -4, -2, -1, -0.5, and -0.25. Okay, and that's the same reasoning as the one that we did before on the previous slide. So let's just speed this up a little bit here, because I know this is taking a bit of time. We have the point -2, -4. And then we have -1, -2, 0, -1, 1, -1/2, and 1, -1/4. I'm going to draw in my horizontal asymptote right there along y equals 0. Okay, and this is going to be what a negative decay model looks like. All right, bear with me. We're almost done. One more slide here, and then we'll take a break. Okay, so the follow-up question is, well, what would happen if we had things being added or subtracted after? So what if I put a +3 here? Or what if I did a -5? What would that do? Okay, so that's what we're going to talk about next. All right, and if you think back to shifts, if we were to add 3 to the end, that means all of the y values in our table, we would be adding 3 to them. So all the y values would be increasing. So that's going to shift the entire graph up 3 units. Okay, so this is going to be a vertical shift. Up 3 units. Okay. So then what if we subtracted 5? Well, all the y values would go down 5. So that means that we would have a vertical shift again. But this time it will be going down 5 units. So that means that the horizontal asymptotes are going to change. On the 4 graphs that we drew, we had horizontal asymptotes at y equals 0 because as we plugged in smaller and smaller x values or bigger and bigger x values for the decay models, we got closer and closer to y equals 0, but we never actually got there. Here, what we're going to do is we're going to be shifting those horizontal asymptotes. So if we're adding 3 to the end, then the HA will be at y equals +3, up 3 units from 0. And if we're doing a subtract 5 at the end, a vertical shift down, then the horizontal asymptote will be down at y equals -5. So whatever your vertical shift is, that's really the location of your horizontal asymptote. Okay? And the last thing is, what would happen to each function if you multiplied by a constant, an a value out in front, like the negative that was introduced into the second problem on each slide? So what does that do? So we already know what happens if a is negative, so let's formally write that down. So if a is negative, the graph reflects over the horizontal asymptote. Okay, and that's exactly what we saw in the second and fourth graphs that we drew. Okay, but what if it's a number other than 1? And this goes back to what we did when we were doing transformations with quadratic functions and linear functions and absolute value functions. So if the size of the number, if the absolute value of a is greater than 1, then the graph is going to be steeper. And then if the absolute value of A is less than 1, which means it's really between 0 and 1, the graph is more gradual. So it's the same transformations that we had when we were doing all of the other types of functions with transformations involved. Okay? All right, so that's an overview of exponential functions and what they look like. Next video, we're going to talk about how to find horizontal asymptotes and determine if it's a growth or a decay model.